Welcome to Study Loop.
Hello, today we have this problem which we're going to solve using the method of variation of parameters. This is a second-order linear non-homogeneous ODE, and we will denote the non-zero right-hand side by f of x. And as usual, the first thing we need to do is to solve the homogeneous equation, which is simply the same equation with the right-hand side being simply 0. And solving this is very simple. We simply write down the characteristic equation that is r squared plus 3r plus 2 that's equal to 0. And once you solve this, we will have the two solutions. R1 is -1 and R2 is -2, which means that our two linearly independent solutions for the homogeneous parts are y1 is equal to e to the negative ex, and y2 is e to the negative 2x. So this means we have these general solution for the homogeneous part, which we can write as y1 c1 y1 plus c2 y2. So the only thing that's missing now is that we have to find a particular solution, which we will call y sub p, and the method of variation of parameters tells us that we need to look for this guy in terms of a nonlinear combination of the two solutions we've just obtained. So we're looking for two functions ax bx such that this this big thing is a solution of this equation. So we could go through all the algebra of by taking all the derivatives, but fortunately for us, there's a very well-known formula for each of this ax bx. So we can simply use that um, um, to obtain our solution. So the formula which I will write down here. So a of x is simply equal to negative antiderivative of y2 times f of x dx, and divided by what we call the Wronskian of our two functions that we've already found. So let's continue this actually. So in order for this, we need to find the Wronskian. So as you might recall from the previous chapter, y1, if you have two functions, the Wronskian is equal to this 2 by 2 determinant y1 prime, y2 prime. And let's compute this on the next page. So this is equal to, remember y1 and y2 were e to the negative x and e to negative 2x. So the derivatives are negative e to the negative x and negative 2 times e to the negative 2x. So computing this 2 by 2 determinant, we will see that this is equal to negative e negative 3x. So what we have to do now is simply evaluate this antiderivative. So now we know all the ingredients y2 f of x, which is this, and w. So let's do that here. So a of x is equal to negative antiderivative of. So I have y2 times f here, so that will be e to negative 2x times sine of e to the x divided by the Wronskian, which is just this guy here. So it's again negative e to the 3x dx here. So after the negative signs cancel and some of the exponential terms cancel, we see that this is equal to antiderivative of e to the x sine of e to the x dx. Now, this is a simple calculus 2 integral, and there are several ways to do this, but you can probably already see that if we use the u substitution um, with this, let's use a different variable t. So if you substitute exponential x equal to t, then we see that dt is equal to dx. Oops. Um, dx dx, so that this is simply equal to sine of t dt. This is because dt contains this e to the x term, and sine of ex simply becomes sine of t. So now this is very simple. It's simply negative cosine of t. By the way, so you don't have to put plus c here, because since we're so if you put plus some c here, then in the end, when you write down an answer, we have to multiply this by y1. So you can see that this term's constant times y1 term is already taken care of in the non-homogeneous solution. So that's why we don't have to deal with plus c constant here. So that's just something to remember. And so let's move on to the calculation of bx. So let's start on a new page here. Uh, so bx, it's technically the same calculation. So this is equal to, if you well, I guess I haven't written down a formula. So it's very similar. You simply get rid of this negative sign, and this will be y1. So bx would be antiderivative of y1 times f of x times the w. So y1 was e to the negative x, and this is sine of e to the x dx divided by negative e to the negative 3x. So after cancellation, this becomes negative e to 2x sine of x, sine of e to the x dx. Now this is already looking very similar to what we just did. We will simply, let's substitute t equals e to x. So then we have dt is equal to e to the x dx. And so we will have negative. So you see that we have e to the 2x here. So this will become t times sine of t dt, because one e to the x comes from dt part, and one e to the x from t part. So we'll have our e to the 2x. So now for here, this again is a routine exercise for the integration by parts method. So if we didn't have this extra t here, then we could directly evaluate this. So our goal is to get rid of this t by taking its derivative, which is 1. So it suggests that we do the following integration by parts. U is equal to t, and dv is equal to sine of t dt. Right? Actually, let's put the negative sign here because we have a negative sign there. So then this would mean du is simply dt. Remember, derivative of t is just 1, so technically there's 1 here. And so from this, we can see that v is simply cosine of t because derivative of cosine is negative sine. Now, so now we'll have this is simply u times v, which is t times cosine t, t times cosine t minus v times du. So this would be integration cosine of t dt. And now this is very simple. It's just this antiderivative is just sine of t. So summarize that here. Now we have t cosine t minus sine of t. And remember, t is e to the x, so we have to um, revert back to our x variable. So we now have sine of e to x. So this, remember, this is our e of x. So we can write down our solution yp now. So this is, remember, so this is ax times y1 plus bx times y2. So y1 and y2s are here, and ax is theta cosine t. Well, I guess I forgot here to write everything in terms of the x variable. So this is my ax. So yp would be y. So let's just write down here x y1 plus bx y2, and ax is negative cosine e to the x times e to the negative x, and bx is here, and multiply that by e to the negative 2x. So it's parenthesis ex cosine, excuse me, cosine ex minus sine of ex times our y2, which is e to the negative 2x. Now at this state, there's usually a calculation. So it's recommended that whatever you've got here, you should open the brackets and look for cancellation. And indeed, in our case, we have one because we have e to the x here and e to the negative 2x here, which will become e to the negative x times cosine ex, which will exactly cancel with this. So I'm going to use a different color to emphasize the cancellation. So this term will cancel with this and this, which will leave us with only one term, that is negative e to 2x times sine of e to x. So this is my particular solution yp. So if I write down the final answer, it will be simply y is equal to yc plus y particular c1 e to the negative x plus c2 e to the 2 negative 2x minus, well, plus yp, but this was minus this function, so it's minus e to negative 2x times sine of ex. And this will be the final answer of our problem.